Welcome today. We want to look at this question. You are provided with the following solutions. M1 containing 95 grams of a mixture of sodium carbonate and sodium chloride per liter of solution. Then M2 which is 1 molar HCl. So this is 1 capital M HCl. What are you required to do? You are required to determine the percentage of sodium chloride in the mixture. So you see now this one is sodium carbonate mixed with sodium chloride. Now sodium chloride here is an impurity. So we want to calculate the percentage of sodium chloride in the mixture. That is our target. Remember, HCl is going to react with the carbonate and not with sodium chloride. So let us see the procedure. Pipette 25 centimeters cube of M1 and titrate with M2 from burette using 3 to 4 drops of methyl orange indicator. Stop titrating when a permanent pink color appears. Now M is going to be in the burette. Therefore, our average is going to be that of M. And what is M? HCl. So that is something used. M2 is HCl. So you should always remember that M2 is HCl. So HCl is going to be in the burette. So let me give you the values. We are going to use 30.3. Our initial is 0.0, and then we will subtract, that is 30.3. The next one I will give you 30.4, 0.0, 30.4, 30.3, 0.0, and then 30.3. So let us calculate the average. Determine the average volume of M2 used. So average M2 used, you always remember this is HCl. So we are looking for the average volume of HCl. Average is 30.3 plus 30.4 plus 30.3. You divide it by 3, which will give you 30.33 centimeters cube. Let us look at the next question. Determine the number of moles of M2 used. Determine the number of M2 used. M2 always remember is HCl. But now you go back. HCl, which is M2, was 1 molar. Meaning that 1 molar means that the number 1 mole means this is the number of moles in 1,000 centimeters cube. So it means that 1 capital M implies this, that it is 1 number of moles, 1 mole, which is equal to 1,000 centimeters cube. 1 M, that is 1 molar. 1 molar. What is a molar solution? A solution that is prepared in 1 liter. So that is our liter is 1,000 centimeters cube. So if 1 mole is equal to 1,000 centimeters, what will be the number of moles of the HCl we used? 30.33 centimeters cube would be what? This times this divided by this, which will give you 0.03 moles. Write down an ionic equation for the substance that reacted. An ionic equation. So we can write the full equation first and then we will write ionic equation. What is reacting? It is sodium carbonate reacting with HCl to form sodium chloride plus carbon 4 plus water. You need to balance our equation like that. So that is the chemical equation, but the equation is asking us to write an ionic equation. So ionic from here, because you can see sodium hydroxide and this one, no, sodium here and sodium here are respected ions, so they are going to cancel out. So here we have CO3 2 minus plus this chloride here, and this one is going to cancel out because it is respected ions also. So we are going to have 2H positive. Remember, this is an aqueous, AQ. This one is also solution, aqueous. So it is going to form CO2, which is a gas, and this is water, aqueous. Remember, gases, water, we don't write ionic for them, we just leave the way they are. So we will have CO2, which is a gas, plus water, liquid, and this is the ionic equation for the reaction that took place. Determine the number of moles of the base used. Remember, the base is carbon 4. The carbonate is the base. HCl is the acid. So this is a neutralization reaction anyway. So we are asked to determine the number of moles of the base used. So we want to calculate the number of moles of sodium carbonate, but we already know the number of moles of HCl that reacted. Number of moles of HCl was 0.03, but the ratio you can see is 1 to 2. So the base acid, the ratio is 1 to 2, but we know the number of moles of this, which is 0.03. So the moles of the base is going to be a half the moles of the moles of the base is going to be a half the moles of the acid. So we will ask if 2 is equal to 3, what about 1? So the answer is going to be 0.03 divided by 2, and that is the number of moles of the base, which is equal to 0.0152 moles. We use what we call the mole ratio. So the mole ratio in this equation is 1 to 2. If 2 is equal to 0.03, what about 1? Let us look at it. Calculate the concentration of sodium carbonate. We want to calculate the concentration of sodium carbonate, but remember, sodium carbonate, we pipetted 25 centimeters cube. So the number of moles we got here, this number of moles of sodium carbonate here, this one, is in 25 centimeters cube. So concentration is in 1 liter. So we will ask, if 25 is this one, what about 1 liter? So we will say 25 centimeters cube of sodium carbonate has got how many moles? 0.0152 moles. Concentration, that is moles in 1 liter. What about 1,000 centimeters cube of sodium carbonate? Would it be what? Moles. So it is 1,000 times 0.0152 divided by 25, which will give you 0.607 capital M. Capital M stands for molarity, or you can write this one as 0.607 moles per liter, moles per dm cube, even dm cube. That is moles in 1 liter. Number party F, Determine the mass of sodium carbonate in 1 liter. Determine the mass in 1 liter. Determine the mass. Here, let me get us. So we have this one. Molarity. Mass in grams per liter, because tumeambiwa calculate the mass in grams per liter, so we will calculate mass per grams using RFM. So we will get the RFM of sodium carbonate. We have the molarity, so mass in grams per liter is very easy to get. Alright, so mass in grams per liter of sodium carbonate will be given by molarity times RFM times RFM. Now molarity, we have it here, which is 0.607 times RFM of sodium carbonate. Sodium carbonate is this one, which will give you 106. 43 plus 12 plus 48 will give you 106. That is times 106, which will give us 64.3 grams per liter. So this is the mass in grams per liter for only sodium carbonate. But remember, the mixture of sodium carbonate, plus the sodium chloride, the total mass in grams per liter was 95. The total mixture now. But now, since we have only for sodium carbonate, we can subtract and get the mass in grams per liter for sodium chloride only. So determine the percentage sodium chloride. So we know total mass in grams per liter of the mixture equal to 95. So 95 minus 64.3, we will get the mass of sodium chloride. So mass of sodium chloride equal to 95 minus 64.3, which is equal to 30.7 grams per liter. But we are asking to calculate percentage. How do you calculate the percentage of sodium chloride? So we will have the mass of sodium chloride divided by total mass times 100, and we will get the percentage. So that is now 30 point. That is 30.7 divided by the total mass, which is 95, times 100, and this one will give us 32.3%. So that is the end of our lesson today. I kindly want to ask you to subscribe, share to your friends, share this love. Thank you, and be blessed a lot. 100 centimeters cube of solution B, that is the acid HCl, were reacted with C, solid C. So after reacting with solid C, some moles were used actually. Therefore, solution D is HCl. That's something which you must also, I want to understand. Solution D is HCl, yes. But which HCl? The excess, the one that remained after reacting with solid C. So it means that solution B was in excess, that is HCl was in excess. Some of the HCl reacted with solid C, and some acid remained, which is now going to react with solution A, sodium hydroxide. It is important for you to understand that. So let us go to question B. Determine the number of moles of solution A, sodium hydroxide, that reacted. Now, the volume of solution A used is 8.5 8.5 centimeters cube. But good thing is that we know the molarity of sodium hydroxide. Solution A is 0.25 molar, meaning that 0.25 is the number of moles in 1 liter in 1000 centimeters cube. What will be the number of moles in 8.5? So we ask that the 0.25 is the number of moles which are contained in 1 liter. 0.25 is the number of moles contained in 1000. Remember, 0.25 capital M implies this. Implies that 0.25 is the number of moles in 1000. Now we will ask 8.5 centimeters cube will contain how many moles? So it is 8.5 times 0.25 divided by 1000. This one is going to give us 0.0002125 moles. That is the number of moles in solution A used, the one that reacted with D. Yes, calculated the number of moles of hydrochloric acid in 25 centimeters cube solution D. Correct. We want to calculate the number of moles in 25. Remember D, which is HCl, reacted with A, sodium hydroxide. Meaning because HCl and sodium hydroxide is the ratio, mole ratio is 1 to 1. Therefore moles of 25 centimeters cube D equal to these moles, 0.002125 moles. The reason the ratio is 1 to 1. Calculate the number of hydrochloric acid in 100 centimeters cube of solution D. Calculate the number of moles of hydrochloric acid in 100 centimeters cube of solution D. Now we have the number of moles of solution D in 25. We got that one. This is what we got in our previous Roman 1. So we ask 25 centimeters cube. Solution D contains 0.002125 moles. 100 centimeters cube solution D will contain how many moles? So it is 100 times 0.002125 divided by 25. This one is going to give us a 0.085 moles. 0.085 moles. Calculate the number of hydrochloric acid. Remember, we are using this question. Don't think that I'm forging the question. Our question is here. The question is from here. Calculate the number of moles in Roman 1, and we are in Roman 3. In 100 centimeters cube solution B. But we know the concentration of solution B. We were given that. So to do it easy, we know B is 0.5 molar, meaning that the 0.5 is the number of moles in 1000 centimeters cube of hydrochloric acid. Now we will ask 100 centimeters cube will give us how many moles? And 0.5 moles of solution B is contained in 1000 centimeters cube. So we will ask 100 centimeters cube will contain how many moles, because this is the original HCl. So it is 100 times 0.5 divided by 1000, and this one is going to give us a 0.05 moles. 0.05 moles. The next question, calculate the number of mole of hydrochloric acid that reacted with X carbonate, X2 carbonate solid C. Now we want the number of moles that reacted with C. This is important now. We have the number of moles of 100 centimeters cube solution B, which reacted with C. And then we have prepared 100 centimeters cube. We have the number of moles in 100 centimeters cube solution D. Now we subtract the number of moles of this D in 100 from 100 B, and then we get the number of moles that reacted with solid C. Therefore, minus moles in 100 minus moles in 100 centimeters cube solution D will give us the number of moles that reacted with the carbonate. So moles of HCl that reacted with C equal to moles in B, which is 0.05, minus moles in D 100, which is 0.0085, and that one will give us 0.0415 moles. Now we have the number of moles of HCl. This is the number of HCl that reacted with C, with the carbonate. But now we can get the number of moles of the carbonate from the relationship between the carbonate and HCl. Now we can write X2 carbonate react with HCl solution B in this to give us X chloride. Not the X, it means it has a variance of 1, therefore you cannot put anything here. So plus water plus CO2. But this X is twice here, so we put 2 here. And then the chloride here is twice, then we put 2 here. So it means that the ratio between the carbonate and HCl is 1 to 2. But we have the number of moles of HCl that reacted with the carbonate. We have the number of moles of HCl that reacted with C. The number of moles is 0, of HCl is 0.0415 moles. So we will ask 1, the carbonate will contain how many moles. Therefore you can see, because this one is 1 to 2, the number of moles of the carbonate is going to be a half that of the acid. So moles of X2 carbonate equal to a half times 0.0415, which is equal to 0.02075 moles. A half of that one. So the next question is calculate the relative formula mass of the carbonate, RFM. We want to calculate the RFM. So RFM, we know we can use this triangle. We know that moles RFM mass. Now we have the mass of the carbonate. Remember, we were given the mass of the carbonate. The mass of the carbonate is solid C is 2.2 grams. And we have the moles of the carbonate is this. So therefore we can get RFM. So RFM equal to RFM is equal to mass divided by moles. Mass is 2.2 divided by moles, which is 0.02075. And this one will give you, use your calculator, to give you 106. So the RFM of this carbonate is 106. Determine or calculate the relative atomic mass of X in the solid C. But we know now, since we have the RFM of the carbonate, it means that X2 carbonate equal to 106. So X, there are 2 of them, so we say 2X plus carbon, which is 12, plus oxygen, that is 16 times 3, will give us 106. 2X plus 60, because this is 48 plus 12, equal to 106. You like terms together, take this one there. 2X is equal to 106 minus 60. So 2X is going to give us 46. So we want the value of X divided by 2 divided by 2. So X is equal to 23. So the relative atomic mass of X is 23. That's fine. And you can guess the element which contains the relative atomic mass of 23 is sodium. So this one is easy to be sodium, because sodium, the carbonate of sodium is written like that. Thank you for your time.